morning, one and all. The subject name is compiler design. In this subject, we discussed some of the definitions and terminologies of definition in the case of syntax analysis phase in the previous session. Now we'll continue the previous definition terminologies in this one also. As previously we have seen some of the what is handles and what are the action that is to be parsers. Now, what is meant by a CLR1 parser indicates that it is a canonical look-ahead parser. In canonical look-ahead parser, that is, we are going to construct a table that is called as CLR1 parsing table. In this parsing table, it produces the number of states when compared to simple LR parsing. Previously, a simple LR parsing, that is SLR, and construction of CLR is called canonical LR CLR. So while constructing this table, we have to compare this with the SLR. And another one, second one is what are the LR1 items. So here LR1 item is nothing but canonical collection of LR of 0 items. That is look ahead is to be look ahead symbols. That is LR1 items is equal to LR of 0 items plus look ahead. Look ahead means LR of 0 items. Previously we have known that means augmented productions which are to be added. The look ahead is used to determine where we place the final item. And this look ahead is always add dollar symbol for the augment production. So this is the most important look ahead. To introduction of the look ahead for dollar, where to that is to be placed for that corresponding argument productions. And what is meant, next one is what is meant by YACC tool. Here Y stands for it, A stands for another, C stands for compiler, another C stands for compiler. That means it is noticed that is described as yet another compiler to compiler. It provides a tool for producing a parser for the given grammar. If you want to produce any parse type of things in the given standard grammar notation, so this type of tools are to be generally used. This program is designed to compile LR1 grammar. LR is nothing but look ahead LR of grammar, and that is mainly specifically used this tool. What is meant by input buffer? What is the panic mode error requiry? Here, in this case, the parser encounters an error. It ignores the rest of the statement and then does not process the input from the erroneous input to delimit like semicolon. This is called as simple error recovery mechanism. Now, some of the problems related which are to be available with the syntax directed translations are syntax directed translations are nothing but these are argument rules and the grammar that facilitate this semantic analysis. And what is meant by syntax tree? It is a graphical depiction of a string derivation. What is our attribute grammar? Attribute grammar is nothing but it is a special form of context-free grammar where some additional information, that is attributes, is appended to one or more to its non-terminals in order to provide context-sensitive information. So here the context-free grammar, in order to that we are going to add some attributes for that one. That means here a dot association of the values, so that is to be considered as attribute grammar. That is syntax analysis to be described. What is synthesized attributes? Synthesized attributes means getting the values from the attribute values of their child nodes. That means the getting, that is, it is A is a parent, B is child. Now the getting the values from the B. So node A get values from child node B. That means here B is processed and that result is sent to A. So A is taking that values from what is inherited attributes. Here inherited attributes take the values from parents or sibling. That means here opposite. Opposite means node B is taking values from value from A. That is here child nodes taking values from A. So this is the opposite of this one. This is called as inherited attribute. Where synthesized attributes, parents nodes are taking values from child nodes. Here inherited, child nodes taking values from the parent node. That means upper values nodes take. What are list different types of attributes? That is, these are called as different types. One is inherited, another one is synthesized attribute. We know what is inherited, what is synthesized with the help of example we have seen. And what is meant by S attributed STD and L attributed STD? S attributed means syntax directed definition. Synthesized attribute, L attributed. Here, the syntax directed translation which uses only synthesized, then it is called as S attribute. Suppose if both means synthesized as well as inherited. Now we know that what is inherited and synthesized. So that both attributes together used, then we can say this syntax directed translation is a L attributed syntax directed translation. If only synthesized use, then we can say that S attribute. Here synthesized only means taking the values from the child nodes. Parent taking the values from child node. That is S attribute. Next, what is abstract syntax tree? Here this is also simply called as syntax notation, where the tree representation which has abstract syntax structure, source code written on programming language. That means parent child nodes, where the node is to be kept at one root node and children are to be processed at different nodes. Again, parents and children, that is a tree structure notation syntax. What is meant by a polish notation? Polish prefix, it is another term for describing a polish notation. So in this, operator is a prefix to operands. And what is a 3-address code? What is the 3-address code? 3-address code is a type of intermediate code which is easy to generate and can easily be converted into machine code. That means the given statement, suppose if any assignment statement is described, so that is to be verified with the number of operators and operands. If not, then that is to be written in the form of a 3-address code representation, so that if that is to be converted, it is easy to process the machine, that means generation of the machine code. It makes use of 3 addresses. That means 3 operands and at least one operator is required, and the maximum 3 operands are used to represent that expression. And the value computed at each instruction is stored in a separate variable notation, that is called as a temporary variable which is generated by the compiler. So this is the main important one, what is meant by 3-address code. And what are the different intermediate forms of the source programs? Abstract syntax tree, polish notation, 3-address code. List the types. Another one is list the types of 3-address code. One is quadruple notation, triple notation. Another one is indirect code. What is quadruple notation of a 3-address code? In quadruple notation of 3-address code, here instruction is specified in quad means 4. So it is divided into 4 fields. First field is an operator, second field is argument 1, third field is argument 2, and the fourth field is the result. That means if you say t equal to a plus b, now argument 1, argument 2, operator and result. So operator is plus, argument 1 is a, argument 2 is b, result is stored in t. So this is the example. Then what is the triple notation of a 3-address code? Here triple notation is represented with the fields such as operator, argument 1 and argument 2. Here the sub-expression, so here the sub-expressions are denoted by the position of the expression. Previously multiple 4 fields, now it is 3 fields, that is operator, argument 1, argument 2. So here the instead of result, the temporary variable is stored, no, that is to be processed with the help of the another name. What is the reversed polished notation? The postfix notation, it is, we know that we have different forms are infix, prefix, postfix. So that postfix notation has to be represented. Suppose if operand A and operand operator, operand B, then that means operands followed by operators. That is postfix notation. So this notation is called as reversed polished notation. So here the operator is postfixed to the operand. That means the operators are available after the operand. So here A is one operand, A is operand, B is also an operand, and operator is placed, operators are allowed after the operands. So that is postfixed to this one. So for example, in this one, A plus B star C. So that's why here the operator is placed in between. So that is processed to the after the operand. That's why you got. Then if you take this expression, star is placed. So AB plus C star. Suppose for example, if you can use this notation, so A, B, C plus and star is placed here. Now for example, in this example, what is the postfix notation? So generally plus is to be placed here, this, and star is to be here. So that's why A, B followed by plus, then C, D followed by plus star. And what is meant by annotated parse tree? Another example is, another definition is what is annotated parse tree. Annotated parse tree is nothing but a parse tree only, but only the difference here is the values of the attributes that is to be processed at each of the node. Each node we are going to specify what are the value of the dot attributed associated value at that particular node can be described clearly for each node. So that is to be processed at each level 1 up, and finally the result will be reached to the root node. So that is to be depicted as a root node as a result. So that is called as annotated parse tree. Where general parse tree, which is used directly for representing the nodes, where the value of that particular dot attribute or association is not mentioned clearly. Whereas in case of annotated parse tree notation, it compulsory uses this value of attributes at that particular nodes, that is child nodes, each child node values, then that is to be described as a annotated parse tree notation. Now what is meant by high level IR? So here intermediate code representation, high level intermediate code is very close to the source code representation, and it can be easily generated from the source code. So we can apply these code modifications to enhance performance. These high level intermediate representations are close to the source code. That's why you can use as fast as nodes, and also we can achieve the performance. What is low level IR? This low level intermediate representation, where that is close to the source code, this is close to the target code. So that's why low levels are very mission specific standards. That one is programmatic standard. So these are used mainly for the storage, registers and memory allocation, set instruction selections, and this makes a difference with this one. So this is the low level representation. What is the 3 address code that is used for the expression A star B plus C? So here the expression, the given assignment statement which contains three operands and 2 operands, which is not a 3 address code. So we can represent with this one as a one temporary t, say t equal to A star B, and this t can be used in the another this one with the plus c, we are going to get another T1. So T1 equal to T plus c, T equal to A star B. So these are the two expressions assignment which is used for the representation of 3 address code for this one. Similarly, what is the 3 address code for this one? So A plus B star C. A plus B is to be considered as one temporary variable T1, and then T2 T1 star C. If you consider T1 this one, then T1 star C with stored in another temporary say T2. So these are the 3 address codes. What is the syntax directed translation for the statement E plus T? So here E equal to E derives E plus T. Now here in this case we are going to write a syntax directed translation attributed associated value. So what is the value of this expression? What is the value of this non-terminal with the corresponding node that is represented by E dot value, which is equal to E dot, the right side of that one E dot value that is attributed associated with this capital E, the plus followed by what is the value that is associated for this T. So T dot value. So this is final. This is the syntax directed translation of the corresponding statement T derives C plus T. What is the syntax directed translation for the statement T derives T star F? Now the dot value is represented as T dot value left hand side, whereas right hand side of the expression that is statement T dot val star equal to F dot val. T dot val star F dot val. Now like this we are going to represent that is a syntax directed translation notations for each of the attribute associated value for this corresponding symbol. Now what are the functions that are used for constructing the syntax tree? The functions are used. First one is make node, that is operand left, right, and make leaf, that is we are going to create a child node, then make leaf id entry, any other child nodes with this one make leaf again value, number of child nodes to be increased. What is the syntax directed translation for the following statement? F derives, that is here F derives digit. F derives statement left hand side F dot value equal to right hand side digit. Submit digit dot numeric, that is lexical value. What is the lexical value that is to be present? Now what is the syntax directed translation for T derives T by F? Here the expression left hand side express T dot val equal to right hand side T dot val divided by F dot val. So this is the described in terms of a curly braces, indicates that the semantic action that is associated with the corresponding statement. Syntax that is the described in the curly braces. These are the two statements which are used for requiring the syntax directed translation. One is it derives digit, second one is it derives T slash F. So only the thing which are used is within flower brackets, and right we are going to left hand side expression T dot val or F dot val, and right hand side that is to be represented with dot association of the corresponding value. So here digit is described, that's why we are going to write digit dot lexical value. If the operator is star, we can write star. If it is a division, so here division operator we are going to write T dot val division F dot value. So for each of this terminal we are going to write the dot associated attribute value for the corresponding non-terminal. So in such a way that we are going to describe each of the assignment statements in the syntax directed translation. So these are the different definitions and terminologies which are described in the phase of the syntax directed translation. All the things which we discussed can be available in the book, that is Compiler's Principal Techniques, Alfred Thielman. Thank you once again. Thank you. We will meet up with one more new topic, definitional terminology, in the next session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.